Pamela,
Fraser.
how you doing?
I'm doing well. How are you doing?
Good. As you can tell, I'm not in my normal blue room.
No, you're in a room with fabulous
You
ceilings.
like those ceilings? Those are pretty
I
great. Yeah, these are
totally
yeah.
dig the
These
ceiling.
are a friend of mine's place, and it's pretty awesome. Um, but yeah. So hey, Astronomy Cast. You know what's also really cool? I'm actually in Central Time right now, so I know what it's like to live in the future like you.
It's a good place to be, although your future is warmer than mine, judging by your t-shirt and my sweater and wool scarf and
Yeah, it's like yeah. I'm in the South. I'm down in Louisiana right now. And it's like 20, 25 degrees out. It's so nice.
Celsius. He's speaking in Celsius,
Yeah,
people.
yeah. But yeah. So I see. I now know that we don't get jetpacks in the future. So
No, sadly
no.
not yet.
Mm, anyway, how's everything going?
It's going well. I think the highlight has been everyone sending me the skydiver almost getting hit by a meteorite and going, "Is this real?" And going, bleh, yeah. "No, I don't think so." But I don't think so. But and I'd love to hear your thoughts on that.
Sure. So I'm gonna say so. Philip Metzger from NASA has run some simulations, and either it's a very tiny pebble, just a few, just like a few centimeters away from the camera, something, a rock,
Yeah,
or it's a very large object, 12 to 18 meters away from the parachute, and
that would have been found.
yeah, so the thought is that it was something that was wrapped up in the parachute. Like I think the evidence, the feeling is that it's something that's wrapped up near the parachute because, I mean, it wasn't falling very quickly. So it definitely. I mean, if you got like a meteorite that hit the atmosphere and then exploded, and then it would have hit terminal velocity and fallen past the skydiver.
Yeah,
But you would have, for it to be sort of anywhere further away than just a couple of feet, it had to be the way the trajectory looked going on the camera. It had to be about 12 to 18 meters away, and it had to be pretty big, like a big chunk of rock.
yeah, and something that big wouldn't have edges that weren't melted was the thing that kept getting me.
Right, and I've heard from quite a few, or we've seen from quite a few skydivers that happens all the time. That if you're packing up your parachute on the ground, you're gonna get a piece of dirt or rock or whatever in there. It
Yeah.
happens all the time, and so it was just that it got caught on camera. So anyway, it's amazing. It's amazing how much effort people are putting into this to try and get to the bottom of it. But right now, the feeling, I think the evidence is going to end up on not a meteorite because
I
it's crazy complicated and difficult for that to happen.
Yeah, yeah, I'm totally with you on that. I'm mostly just amused that the number of people emailing me. I fear for Jeff Nopkins' inbox right now because he actually is a meteorite
Yeah,
person.
yeah,
Um, it's
yeah.
awesome to
So
see all of the excitement. I wish all of the excitement led to lots of people staying excited, and I hope that
well,
becomes
they'll
the
be excited
case.
because on April 15th, we're going to have a total lunar eclipse. It's going to be visible across all of North America.
That's true.
So we're going to have just a stunning show in the sky, and everyone should get jazzed up. And then we're going to have like four of them, I think, over the course of the next little while, the tetrad, and it's going to bring about the end of the world. So, enjoy while you can. Gather your
It's
loved ones
Astronomy
close.
Cast. We always talk about death from the skies.
Death from the skies and the universe trying to kill you. No, there's nothing that's going to happen except the moon's going to turn red and it'll be fine.
It would be beautiful. I shall do photography, should I be able to.
Yeah. Oh, no, we're going to try and live stream it. So yeah, absolutely. Okay, so if you're wondering what on earth you've stumbled into, this is going to be a live episode of Astronomy Cast. Now man, it's a very echoey room. I need to put like blankets everywhere. I wonder if they'd be fine with that. So, right. So man, it's like I'm in some kind of chamber.
You suddenly sound like it's auditorium, Fraser.
Yeah, totally. Right. Okay. So last week we did Werner von Braun, and then we were going to do Werner von Braun's technologies, but you and I both really kind of felt like we had covered like the V2 and the Saturn, and I think our natural inclination was to veer towards those technologies, and also the Nazi horrors, but also the technology. So I think we felt like we've covered that. Now we've got on our big list ideas, Apollo 11 and the Saturn V, and so I would love for us to do a really detailed look at some of those bigger specific pieces of equipment down the road. So maybe we'll punt that down. So instead, you proposed a topic which is essentially, what do we do with spacecraft when it's time for them to die? You know, we take them on a walk out back.
No, don't phrase it that way.
Yeah. Come on, buddy. Come on, buddy. Time to go and image.
No, shush. You don't own pets the way I do. Shut up.
So I don't. So we're going to talk about sort of what do we do with these spacecraft once they've reached the end of their life? Do we, and especially because they're far away, and in many cases there were no plans to deal with them in the end. Like, people would just fire them into space and then not really think about the future. So it's time for us to think about the future of these spacecraft. So we'll take about 27, 28 minutes, depending on how well I can wrangle Pamela. And then at the end, we'll stick around and we'll answer some of your questions about space and astronomy. So, yeah. So stick around. Now you can interact with us using the Q&A app, and you can do that from. You should see wherever you're watching this video. You should see something that says Fraser Cain is answering questions. Click here to join the conversation, and you can just click that, and you'll come into the Q&A app, and I can see a bunch of people have already done. Fraser has a fan, says Ronald Minch. Not only do I have a fan, check this out. I have two. Yeah, isn't that awesome? So yeah, I have two fans, not just one. Cool. Okay, so you ready to record? Mm-hmm. Okay.
Are you ready for me to record?
I am ready for you to be ready to record.
I'm pressing record. It is
I am
recording.
also pressing record. Oh, audio level is a little low. We'll see what happens. Preston's probably going to kill me. And it's very echoey. I apologize, Preston. I'm in a very echoey place. Someone's saying that you have the wrong mic.
I wonder if that's why you sound so echoey.
Oh, well, I'm using this mic. I'm using the camera mic because I've found that if I use my Blue Snowball, people have been saying that it's been kind of echoey. So I'm using the Blue Snowball for my recording, and I'm using the camera mic for the YouTube, the live show. But okay. But apparently you have a hollow sounding mic.
I have a hollow sounding mic?
Mm-hmm.
My levels are really low, and I don't know why.
Tap your mic. Nope. Wrong input.
Okay, hold on.
Thanks.
Hey, it's using the microphone that's sitting on my desk. We're sorry. I'm sorry.
That was entirely my fault.
Whoa.
Hello.
Okay, well, do you know? Okay, that's not fair. Okay, let me switch. I'll see if mine fixes as well. Hold on.
I'm going to stop my recording. We can restart this recording.
Yeah, I'm going to start. So I've switched to my.
So much better.
Does that sound better?
Yeah.
Does it sound echoey? Because last time I did this, people were like super echoey, but.
The other one was more echoey.
Yeah. So this is fine. Okay.
Yeah.
Thanks for man. I love having the live audience. Isn't that just the best?
Yes, it is. So should I press record again?
If you want.
I'm pressing record. Hi, Preston. You don't know it, but we just saved you many moments of laughing at us and having to cut it off because neither of us had the correct mic in
But
use.
Now we have the right mics. And hello, Preston. And once again, we thank you for your awesome editing. Okay, here we go. Astronomy Cast, episode 342, Sun-Setting Spacecraft. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. I know I'm sounding like a broken record, but I would like to plug.
Okay.
The Hangout-a-thon.
Yes, April 26th, 27th. I'm actually going to start posting blogs about that today. So last week, for those of you listening to the audio recording, you'll have multiple things to catch up on, where I'm going to talk about the history of CosmoQuest and what it is exactly that we're looking for funding for. So, you know, hopefully many of you out there have jobs. If you don't, we hope you find them quickly. And if you want to consider getting your employer involved to help sponsor us, we're looking for corporate sponsors, we're looking for clubs to donate money. Right now, I just got back from the National Science Teachers Association meeting in Boston, where all of us who do astronomy education at one level or another, we're pretty much walking up to each other and going, are you okay? Are you going to make it? And it was like we were talking to a bunch of other terminally ill individuals because, well, NASA's budget for doing citizen science, for doing education, for doing communications, all of those fabulous things is currently less than what one individual reportedly spent for a commercial ticket to go around the moon someday in the future on unproven technology. We need help, and we're hoping that you'll help us define the future of astronomy, citizen science, education, and communication with your business, your friends' contributions.
So what's the date again?
April 26th, 27th. We're going live at 10 a.m. Central, 8 a.m. Pacific, 4 p.m. London, and we're going live for 36 straight hours.
Nice. I mean, it's going to be pain and suffering, but in the cause of raising funds for CosmoQuest and astronomy research. So, okay, great. One last reminder is that if we've timed everything right, you're listening to this on April 14th-ish.
Yes.
And if so, tomorrow, on April 15th, is going to be a total eclipse of the moon that should be visible in all of North America. So if you want a good time, we highly recommend that you do that. Head outside on April 15th around, well, it depends on what time it is.
But if you don't know what time it's going to be where you are, Fraser has an app for that, and I just needed a reason to say he has an app for that.
I have an app for that, yeah. So it's the Phases of the Moon app, which I'm holding up to the video, but you can't see it. So anyway, when you check it out, it turns, let's see, it should turn red. Oh no, not in that one, the Pro version. Anyway, sorry, Preston. Anyway, it turns red on the Pro version for the lunar eclipse, which is really cool.
So go ahead, get that Pro version, and get yourself outside and enjoy the lack of moon.
Yeah, we're gonna have. I mean, it's been a long time since we have a really nice lunar eclipse, so this is gonna be great. Anyway, people don't stick around for our jabber. Let's get on with the show. Okay, here comes the intro. So everything dies, including our technology. But when we've hurtled a few thousand pounds of robotic instrumentation to another planet, it gets a little difficult to shut it down and clean up. So what do we do when a mission has reached the end of its useful life? What do we do, Pamela? Now this, let's provide some examples of some spacecraft that have reached the end of their utility.
Well, I think my favorite case of end-of-lifing a spacecraft is Galileo.
Yeah.
The Galileo probe orbiting Saturn, they wanted to make sure that it didn't accidentally crash land on one of the water-rich worlds out there, one of the moons that just might potentially have life. And so they crashed it rather harshly into the surface of Jupiter and continued to take data from it until Jupiter's atmosphere had completely destroyed it.
Right, but it's funny that they did this. Like, had they not, when they launched this mission, I guess they didn't know necessarily the extent of the liquid water on the moons of Jupiter when they launched Galileo. So they hadn't really considered that it was a potential host for life. And then they launched the spacecraft with its, I guess not a very clean environment. I mean, there's absolutely going to be bacteria all over Galileo, and as we know, that hardy bacteria can last for thousands, hundreds of thousands of years under really extreme environments and come back to life. And so, yeah, if you crashed Galileo into a nice, warm environment, wet environment, that bacteria could get rolling.
And on surfaces like the surface of Europa, while Europa is very, very cold, it's getting squished and unsquished in a very systematic way by Jupiter so that its core is molten, and the heat from that is causing there to be liquid oceans between the icy surface and that hot core. And you can envision a spacecraft with sufficient kinetic energy hitting that surface and hitting it in one of the areas that perhaps is already weak. There's the chance that it's going to go through, and instead of sending smallpox blankets to Europa, we're sending, well, bacteria-rich, moral equivalent of smallpox spacecraft and killing off whatever life might be there, and that would be horrendous.
And this same strategy is probably going to be in place for Cassini, because there now it's come to light that there is probably a water-rich environment in Enceladus and some of the other moons
Titan
potentially.
has methane ecosystem.
Although with Titan, they landed Huygens on Titan, and it's there breeding its nasty bacteria all over the surface of Titan.
But that doesn't mean they want to make things worse.
Right. So it's the same. Once Cassini reaches the end of its lifetime, they will crash it into Saturn and hopefully get the same kind of death,
and this is
as
why
it falls into the planet.
And this is why I'm bringing this up now, is we're looking at a number of different NASA missions due to budgetary cutbacks getting end-of-lifed, and some missions you can end-of-life in easier, less hazardous to the spacecraft ways than others. The Wide Field Infrared Survey telescope that was up, the Survey Explorer, WISE, a few years ago, when it hit the end of its natural funding cycle, they essentially put it to sleep. But it was very much a Sleeping Beauty scenario where it got boosted to a higher orbit, waiting for the kiss of signal that would wake it back up and allow it to be used again. And they're waking that telescope back up and putting it back to use. So it's possible for some missions to get put to sleep with the chance of possibly waking up again in the future. And others, like Cassini, the only thing you can really do is kill them.
Okay, so let's talk about a few scenarios then. So let's stay close to home first. Let's talk about the kinds of spacecraft that get launched into a low Earth orbit. Something like the same altitude as maybe the International Space Station, or maybe even the International Space Station. So what gets done with spacecraft like that?
So low Earth orbit things are either quick experiments. Pretty much all the CanSats and smaller are in low to excruciatingly low Earth orbit. These, in some cases, are spacecraft that are spy satellites that go over the same part of the planet every 4 days, that just have nicely resonating 90-minute orbits that fit politely into a 24-hour period. These are not weather satellites. They are generally not communication satellites. They're things that are either looking down or running experiments. And they're happy there until they're not, because there's a fair amount of, well, there's still particles. Saying atmosphere is easily makes people overthink it. There's very thin parts of our atmosphere still up at the 300-mile mark, and that frictionally slow spacecraft that aren't constantly boosting themselves up. And so things in low Earth orbit are eventually going to come down.
Right. So the atmosphere is going to take care of this problem for us.
For the most part. The problem is the atmosphere doesn't always take care of it enough. So there were cases of when Skylab landed, Skylab didn't so much land as it went through the atmosphere, shredded itself, and chunks of it scattered itself across Australia. Wasn't exactly the best thing we have done to the nation of Australia in the name of space exploration, but that's what happened. There was the case of Operation Burnt Frost, which is one of those fabulous military code words for we had a non-functioning U.S. satellite that had a hydrazine fuel on board, which is highly toxic. It got blasted apart to make sure that there were hopefully no pieces big enough to make it all the way through the atmosphere and do something destructive on the surface of the planet. So we like to destroy things thoroughly when they come down from low Earth orbit so that chunks don't kill people.
Right, and same thing with Mir, right?
Purposely put into the ocean.
Yeah, and so I mean, we were really fortunate, right? With Mir, they had a spacecraft attached to it, and they could deorbit it when and where they wanted. But for a lot of these spacecraft, they don't have any kind of deorbiting technology on them. You literally just have to wait for them to run out of fuel to boost their orbit. The atmosphere finally drags them back into the atmosphere, and wherever they re-enter is where they re-enter, and in most cases, most of it breaks up, but some of the chunks make it through. And we went through this with a bunch of spacecraft over the last couple of years. I remember we were on these live watches for when, was it Fuse came back? And
every few months it seems like there's a new Twitter storm of activity of, do we know if it's down? Do we know? Do we know? And I mean, the reality is that basically NORAD can't see it eventually, so we know it's no longer up there.
And they're calculating the odds that it's going to hit and kill a person, because there is a chance, because there are big chunks, and some of them survive the re-entry and crash to the Earth. Most of the time, they just fall into the Pacific Ocean, but sometimes. Okay, so we've dealt with, I guess, the spacecraft that we put into low Earth orbit, in that we don't really have to deal with them. We let the atmosphere deal with them.
Bye-bye.
But if we're feeling, careful, we'll put some kind of re-entry rocket on it and deorbit it faster. I'm assuming that's what's going to happen with the International Space Station at some point, right?
Yeah, that's the plan.
Yeah, because I mean, it's coming
big.
back down. It's big.
And yeah, so let's just see how long we can keep that sucker up there. That will be easier. And there's always the cool potential with manned things like that. And the Soviets actually did this with some of their spacecraft, and the Chinese have made noises about potentially doing this in the future, that you take part of the old station and put it into whatever's the next great thing that you build. So that's kind of the ultimate in recycling. Oh, we've got solar panels already, don't need to carry any new ones up. Hey, this particular part of the station doesn't smell too bad. We'll clean it up a bit and keep things going.
So we've got those. The Hubble Space Telescope is another example of a spacecraft that we're going to have to figure out what we're going to do. And during a previous mission, they figured that part out.
So yeah, there was the long debate of, do we burn it up, do we boost it higher, and so there is now attached to it both the ability to grab it and the ability to move it. So there's hope that destruction will not lead to death of humans.
Right, okay, so let's talk about some other spacecraft then. So we've talked about the low Earth orbit. So what about a little bit of a higher orbit? We've got something that maybe is 500 kilometers, 1,000 kilometers, something that's not going to get dragged down into the atmosphere, stuff that's on polar orbits. Some of the navigational satellites are at this sort of mid-range altitude. What do we do about them when they reach the end of their life?
They pretty much get to die in place, them and everything higher than them. Occasionally they will move things to new orbits before they completely die, and this is simply so that you can park a new spacecraft in a preferred orbit. You can imagine if we left everything that gets put into geosynchronous orbit in place, you'd end up with eventually a solid band of spacecraft around the Earth's equator, many thousands of miles up. We're a long way from that happening, but there's still preferred places to be if you want to make sure your signal is perfect for some metropolitan area, that your weather is ideally getting that range of the planet that you want to be able to predict. So they do tend to move those things into what are called parking orbits, where they're pretty much out of the way and can peacefully stay. And until there's actually many different nations that are working on plans to build things that will grapple on and either retrieve, bring back down to Earth, or destroy these dead satellites that are cluttering up the Earth.
Right, and this is one of the concerns, right, is this idea that we're enclosing the Earth in this shield of metal, right? We're not
Yeah.
worried about the stuff that's that's at the low Earth orbit, because it's all just going to get brought back in with the atmosphere. It's that next level out where you've got these spacecraft and they're going to be crashing into each other and shredding each other and making smaller and smaller debris particles, and eventually you might get this, mist of, dust-sized particles of spacecraft going at 25,000 kilometers per hour, and it will just make any attempts to kind of move through it like moving through I don't know, some kind of grinder,
Well, it's really kind of terrifying to think of the day when it's possible economically to put CanSats into higher orbits, because right now all of these little anything from bucket to circuit board sized spacecraft, they're all going into extremely low orbits where they're going to eventually be heated up, melted, destroyed by the Earth's atmosphere. That's good. And the reason I say that this is good is because NORAD, which is one of the primary facilities that tracks space junk, they can't detect and track things that are really smaller than a can of soda. And so these circuit board spacecraft, we can't see at all. You really need to be bucket sized to be reliably tracked. And so if you can launch a couple hundred of these easily on one big rocket, you're literally going to end up with swarms of amateur telescopes, amateur communication satellites, research devices, making it impossible to get the big things up there safely. And already we're moving the International Space Station on a regular basis to get it out of the way of this piece of junk or that piece of junk. I know the mistakes my students make in the classroom when they build robots. Now imagine that they're building robotic spacecraft and those mistakes are being allowed to orbit the planet.
And the miniaturization is going to keep going, and you're going to end up like right now, as you said, CubeSats are now big. We're on to eighth of a CubeSat, like just what look like little. They just look like circuit boards, and circuit board sats. And the next thing is they're going to be fragments of them. You're going to have entire satellites that are completely miniaturized, whatever is the minimum size to get a camera and communications. And you can imagine these grid mesh networks communicating with each other around space. So the spacecraft just keep getting smaller, and you're launching like buckshot into orbit.
Yes.
And so I totally agree with you that this is of interest. So spacecraft designers, how do you plan to get your microsatellites back down and crash them into the Earth's atmosphere? Okay, so we've got that GPS, sort of the next layer, same kind of problem.
Yeah,
but it's a bigger space.
Well, from there it's basically all the way up. You either put them in a parking orbit so something else can take over the orbit you're in, or you just kind of let them die in place and peaceably keep orbiting the Earth until something goes and grabs them and goes, bad rocket, go over here.
Now what about when we get to some planets or some other objects like the moon? Like we've got NASA's LRO is at the moon right now. Laddie's at the moon. What's the plan for them?
So we don't normally think about it, but the moon does have enough of an atmosphere to do bad things to spacecraft. And these science spacecraft that we have that are taking amazing, beautiful, high-resolution images are only orbiting a few tens of kilometers above the surface. And that's enough for them to be experiencing drag such that if you let go and ignore them, they're not going to keep orbiting the moon forever.
Yeah, and they're getting like awful tidal forces between the moon and the Earth, and you can literally not have anything stable around the moon for any long period of time. They're all coming down.
And this actually allows us some pretty awesome scientific moments. The inspiration for this particular episode was the recent press release about, it's the month of April in the year 2014, and Laddie's going to land catastrophically this month. This is the way they phrased it is, this is not a landing you can walk away from.
This sounds like all of my Kerbal Space Program landings on the moon in the Kerbal Space Program.
Right.
No one's walking away from any of my landings.
So Laddie is working on detecting the lunar atmospheric dust and environment, and the closer it gets, the better the data it's getting in some ways. And so they're working really hard to make sure that they can boost it over mountains when they need to, and people forget how extreme the topography of the moon is. There are kilometer-deep craters, kilometers high ridges. It's a dynamic surface. This is why Galileo, with his little tiny telescope, was able to make out that the moon is not smooth. And so they're hoping that it will get lots of data until it's very close to the surface, but there's always the random chance that it's going to smack into something on one of its low orbits. But the lower it gets, the more data it gets, and it's really kind of awesome.
We've had situations where we've landed a mission on an asteroid.
Yes,
right?
the near Shoemaker mission.
Yeah.
This one was really awesome because it wasn't fully planned out ahead of time that this was how it was going to end of life. And they basically were able to get all the way down to the surface of the asteroid Eros and just kind of gently plant themselves there. And that is awesome on so many levels because, first of all, asteroids are tiny. Orbiting these things is an insert word that you use to describe finding a needle in a haystack. It's a challenge because they don't have that much gravity. You have to match your orbital velocity around the sun to theirs before you can transfer into an orbit around them. They're rotating and just trying to match your orbital speed, the rotation speed, all of these different things together and touch down softly. Well, they managed it with this little spacecraft, and this is why we have such good data on this particular asteroid.
Yeah, just amazing. And so we talked about Galileo. We've talked about what Cassini's going to be doing. Now, what about the rovers and the orbiters at Mars?
And here's another one of these great cases of we aren't recycling so well. We are slowly littering the surface of Mars with dead spacecraft. There's a bunch of great comics all over the internet about aliens walking across the surface and just seeing everywhere they look these dead rovers kind of everywhere. And we periodically have crashed other things that weren't quite meant to crash onto Mars. And so Mars is a place where I can imagine 500 years from now, little historic signs all over the surface saying, in the crater ahead, you can see the wreckage of, and the moral equivalent of velvet ropes marking off where we've left things to die. Poor spirit.
So just to be clear, they're just crashing them, and that's that, and they're not doing any, attempt to decontaminate them. They're just.
Well, we do
Mars.
with Mars things try and get them clean ahead of time. So Mars is one where we have put an effort in to hopefully have a few less extremophiles. But things like Mars Spirit rover just kind of got stuck in a sand dune and died there, and you can imagine that over the years the sand will perhaps blow up over it and it will become a sand dune, and just like people have unburied entire towns and cities in the desert of the Middle East, someday archaeologists will be unburying rovers in sand dunes on Mars.
That's a good point. That they'll be totally hidden under sand and dust within
Mars
a few hundred
Phoenix
years.
already is during the winters.
Yeah. Now, what about some of those spacecraft that are sort of on these one-way trips out of the solar system? The Pioneers, the Voyagers, New Horizons. Any way to sunset them?
So their sunset mission is kind of to go off and be the ambassadors of humankind. So it's sort of like the elderly statesman who in his final years you send him off to be an ambassador in a nation that you're not too worried about screwing up the politics.
Aren't we really just like letting them run out of power and die in cold space?
Yeah, but they have friendly messages painted on them.
Oh, great. Yeah, you just take your aging senator, throw him out into space, cold, let him freeze solid, but with a message painted on him. Fire them off. Yeah. I'm sure some people may want to do that with their senators.
I can now imagine them like Sharpied with
yeah, exactly. You can have them. We don't want them.
Here's the pulsar map.
Right. But I mean, I guess
there are silent ambassadors.
Yeah, they will gather every piece of data they can out of the spacecraft until the very end.
Yes, and luckily these are spacecraft that were built before we really seriously ran out of nuclear fuel cells for the radiothermic generators, and so they can last for an extremely long time. We're still periodically getting data back from the Voyagers, and it will be interesting to see what happens as they get. Well, they're already beyond the sun influencing part of our solar system.
And you know what's the saddest? The saddest way to sunset a mission is to run out of budget.
Oh my God!
Operating it, but the spacecraft itself is still fine,
and this could happen to Cassini.
Mm-hmm. There's no way it's going to happen to Cassini. Like, I know it could happen. I promise you, I'm going to go talk to the Prime Minister. The Canadians will take over. Don't you worry. The Canadians and the Europeans, we got this. But there's a lot of spacecraft that are currently in the same concern right now that there are missions. Cassini's one. Messenger, yeah. There are spacecraft right now that, because of budget shortfalls, the solution is going to be just turning off the switch.
The way this is phrased is they're under senior review. And what that means is the funding for education, public outreach, and communication of the mission's science is zeroed for the most part. They can keep maintaining their websites. But they're under review and in a only spend the money that's necessary to keep your mission operating budgetary situation. And not all the missions come out the other side of senior review. Some come out with extensions, some come out with parking orbits like WISE did, and others come out with, we're going to crash you into the surface of whatever world it is you're orbiting. Goodbye. You served us well. You're now dead.
So has that happened? Are there missions that have actually just, for budgetary reasons, they've just shut the mission down, and they just, even though it was a perfectly operational mission, they've just stopped receiving
They
data
did that to WISE.
Yeah. That's
exactly what happened to WISE. And right now, I mean, to look at the things that are undergoing senior review, we have Chandra is approaching senior review. Lunar Reconnaissance Orbiter has been in and out multiple times. I've lost track of its current state. Messenger's under senior review. Dawn. It hurts to look at the number of things that could be taken away from us because they've completed their initial mission. They were engineered so that they can keep going, and
yeah. I mean, you feel that the engineers are like, we need this to, or the mission planner's like, we need this to run for 3 months, and the engineers are like winking at each other, like, yep, no problem, it'll only go for 3 months, and they're like, 3 years, 12 years, no problem, we got this.
Right. Yes.
You look at how long Spirit and Opportunity's still going. It was a 3-month mission. It's lasted, what are we, 10 years now? Crazy, right? Just how long these missions have lasted. So the engineers are building these spacecraft that are capable of delivering us science for a decade plus, and yet the budgets for the ongoing maintenance of these missions isn't set aside and isn't earmarked to last.
And the problem that we're looking at is twofold. The more missions we have living longer and longer, each of them have their own sustainability costs. You have to pay the mission engineers, you have to pay for the communication time, you have money going to the scientists doing research with the data that's coming down. As you end up with more and more spacecraft, you have more and more of these costs that start to build up. So, okay, fine. So, in the perfect universe of a continually growing NASA budget, we can handle that, and some of the costs go down over time. You're also faced with the but now we want to go to Europa. Now we want to go to Neptune and Uranus. We want to see the outer solar system. Well, you need to find the money to do that. And then the reality is we don't have that growing NASA budget. Like I said at the beginning of the show, right now at conferences, it's like we're terminally ill patients wondering how much longer we have to survive because Congress keeps cutting back our funding. And with flat costs on operating spacecraft, the only thing left to kill is the human salaries or the spacecraft, and it's usually both.
Right. Well, and on that sad note, thanks a lot, Pamela.
Thank you, Fraser.
We'll talk to you next week.
Okay, bye-bye.
Okay, hang tough, everybody. We will save.
Yep.
And then I will export. I will upload to Dropbox. Why won't export? Okay, I'll figure that out later. One problem. Okay, sorry, apologize. I have to decide whether I'm going to focus or try to entertain people while I'm focusing. I've decided I'm going to focus. Okay, so let's get on with some questions. So Hugo Burnham notes that Laddie is going to be allowed to crash onto the far side of the moon around April 21st. So that's soon.
And that is presuming they successfully miss mountains.
Right. It's going to be close. Like to actually exactly predict when this is going to happen is going to be tough.
And they're actually encouraging people to basically place bets on when it's going to actually crash on one of their websites.
I am totally going to place your bets. Okay. Stuart Rosenberg says, off topic, I just found a photo of a total eclipse from 1924 from my father's collection of old photos. Awesome.
You need to post that online and tag us because I would love to see it.
I'd love to see it. I'll totally share it. RJ Robledo says, any opinions on the upcoming SpaceX Dragon capsule launch? When's the next SpaceX launch?
I thought they had bumped it to Q1 2015.
Well, because there was all these problems, right? And
so they did have to delay it. I'm a fan. They launched a Wheel of Cheese. I pretty much squeed at that and became their fan because they have excellence in engineering and humor.
Let's see. So they're targeting the SpaceX Falcon 9 is going to be with the CRS-3 Dragon is going to be April 14th. So that'll be a week from today.
Okay, I'm thinking of Heavy Lift is Q1 2015.
Yeah. So I love the Dragon. I wish I've seen one in person. I visited SpaceX and got a chance to actually see the Dragon, the one that had already launched with the Wheel of Cheese. They've got it hanging in SpaceX, and I've got a picture of me in front of it. It's amazing. SpaceX is the best place ever. It's Disneyland for space nerds. It's amazing.
And one of the things that saddens me in ways that I don't even really have the vocabulary for is I think that the current issues going on in the Ukraine and how the US and EU are working to respond to those is going to lead to an acceleration of the US manned space initiative and a sense of urgency that wasn't there before. And I'm hoping that sense of urgency puts us on a faster track without decreasing the safety of that track.
I understand.
Competition gets things done, but it hurts.
Yeah. But I think, I mean, I know that this is good for SpaceX, and I know this is a good, it's just too bad that it had to go down this way.
Yeah.
So, Guido Bieber says, is there any thought about the space junk in the Apollo era? I remember here that the Apollo hardware is still somewhere around in space. I don't know what they routinely did with the command modules. Yeah, every now and then, chunks of Apollo era stuff flies past the Earth. I'm trying to remember what it was. There was a Saturn upper stage booster that was in a weird orbit, and people thought it might have been. They thought it might be like a captured asteroid.
No,
and now
chunk
they
of a
think
Saturn V.
Yeah, they actually think it was a chunk of a Saturn V. So we do interact with chunks of Saturn V. Some of them are gone. Some of them they brought big chunks of it back to Earth. Some of it's crashed on the moon. Some of it's flung out into space. So they weren't that careful about where all this stuff ended up.
And one of the awesome things that I learned over the weekend, although it's probably been on the internet much longer, but I just learned it, is they've been able to use the Lunar Reconnaissance Orbiter images of the various Apollo landing sites where flags were planted. And they've looked at series of images that have the sun in a variety of different places, and they've been able to see the shadows of the flags move with the sun angle, such that while you can't really in just one image make out the flag's shadow because the flags are so tiny, but by combining and looking at multiple images with multiple sun angles, you can say, what? Yes, they're still standing. So the next question is, has the sun's ultraviolet light completely bleached them out? And it's going to take getting back to the moon to find that one out.
Yes. We actually have a video coming up on this topic that we did in about a week and a half. We got about how do we know the moon landings weren't faked. We did this on the Universe Today.
Cool.
It's good. Nancy Graziano says, how feasible is it for some of our inner solar system spacecraft to have a planned suicide into the sun rather than contaminating one of the planets?
Getting to the sun is not entirely straightforward. It's much easier to orbit it than to get to it, depending on where your actual target is. You have to have a pretty big energy change to go from a nice orbit in one of the Lagrange points or orbiting a planet or something to end up plunging to the sun. And a lot of the spacecraft don't carry enough energy to make that kind of an orbital transfer.
Next one. Richard Strassel says, will Cassini keep doing science as it goes down, and we get some interesting readings from Saturn's atmosphere?
It should.
Yeah, totally. We will get the what is it like to fall into Saturn's atmosphere data. And
match it to Galileo and slowly but surely.
Yes. Right? That you will look at what it was like for Galileo to go through the atmosphere, and then you look at what it was like for Cassini to go through the atmosphere, and that'll tell you things.
Yeah.
Things about what it's like to kill your spacecraft.
This is such a morbid Monday afternoon conversation.
Yes. Okay, so Guido Bieber says, oh, and side note, please don't forget to embed the original video. I totally apologize. I just did that now. So I forgot to embed the live video over on the event page. So I've just done that.
Sorry.
Sorry, but it looks like a lot of you found us over here. So, yeah. I have a lot of things to do.
I always tweet it, so.
I couldn't get a chance to tweet it. I was wrestling
follow
with
CosmoQuest X and Astronomy Cast on Twitter, and you'll get this, and you'll get all the rest of our shows as well.
Nicole Gallucci says, haha, bleach flags, moon people, we surrender. Hey, Nicole. Hey, Nicole handled the Weekly Space Hangout last Friday, and I really appreciate it. She did a fantastic job. She is the best host. Helga Bjorkog, our good friend and a long-term supporter of all the things we're doing.
He's awesome. I
know, right? And Glider Pilot, who has got me totally stoked to go glidering at some point. I'm coming to Scandinavia to come glidering. So he's made a slow motion of the shoot unfold, and he knows what he speaks. And so he's got a link. I'm trying to think where. someplace you could find it. I know Phil just updated his article about the meteorite.
This is Phil Plait over on Slate.
Yeah, and so he's included. I think he's included some of the data from Helga. So check it out. Eric Blanchard says, "What's the name of that satellite that went dark for a long time and then randomly came back online? Do you recall that?"
WISE.
It
didn't randomly. They purposely turned it back on.
Yeah.
There was.
Kepler has been.
No, it's not there. It's one of the comet orbity ones. So Rosetta purposely got turned off for a long time. They're waking Rosetta back up. That was done purposely. It was put into hibernation mode while it was at a great distance from the sun. I don't think that's the one you're talking about.
No.
There was a sun-orbiting one that they bring awake periodically, and I'm totally blanking on its name. We've been launching a lot of stuff for 50 years.
Mm-hmm.
Someone needs to write a Wikipedia article on this. Internet, go.
So if someone can tell us, what was the name of that mission? It wasn't Rosetta. Unless that's what you're talking about.
Yeah, Rosetta was purposely put to sleep. There was the Epoxy mission, which was repurposing. Was Deep Space One.
Yeah, that was Deep Space One. Yeah, and the problem is I'm trying to search for it now. This is all just Rosetta stuff. So because it happened about a year ago, we would have figured it out. So anyway, Internet, we request your help. Carlito Brigante says, "Love you guys." We love you too, Carlito.
Thank you.
Thank you so much. Okay. Ask an Atheist says, "How long will it be before we start to understand the cause of the singularity?" Now, we're not talking about the technological singularity here. We're talking about the, I guess, Big Bang singularity.
Oh.
Do you think that we will get to understand the nature of the singularity that caused the universe?
I think that there's still even debate over whether or not it was a singularity or a wave function that simply collapsed down to a new state. The new inflationary signature found in the cosmic microwave background is something that needs more high-resolution data. It needs more probing, but it's unclear whether there's anything in terms of data from before the formation of the cosmic microwave background that is left to be found once we're done understanding that signature. The problem is we can't observe directly the early universe, and without the ability to make direct detections, we're left with creating theories that match the data, and it's often possible to create multiple theories that match equally well.
Mm-hmm.
So I don't know. I kind of think that there's always going to be a certain amount of mystery.
Really? So you feel like what came before the Big Bang?
What came before the Big Bang, I don't think we can get to full stop. But what came before?
What were the conditions? What were the conditions that caused the Big Bang?
I think any understanding of what the universe was like prior to a Planck time after the formation of the processes of the initiation of the processes of the Big Bang, we will never have a definitive answer to.
Yeah. It's interesting. I mean, I actually posed a question like this to Lawrence Krauss, although he, a few years back, I did a recording with Skepticality. It was not exactly on this, but he really feels like there are questions that we may never know, and the more we know, the more those questions will become unknowable. So,
I agree.
Yeah, that there is definitely a limit to just how far science can take us, and there may just be a certain point that we just can't resolve it with the kind of resolution, right?
We have the Heisenberg uncertainty principle that says with any specific thing, you can either know exactly where it is or exactly how fast it's going. Well, momentum is the word they usually use. When it comes to our universe, we're limited in terms of Planck time, Planck distance, in terms of we just can't probe smaller than these things.
Yeah.
And I don't know if we'll even get quite to that stage because there's the cosmic microwave background as that wall of understanding that surrounds us. We can't stick our head through it.
Yeah, exactly. The Heisenberg uncertainty principle may get to the point that it's the overpowering concept at a certain resolution, and that you can't
And the
probe any
Planck,
deeper.
the Planck time, the Planck distance,
Yeah.
all of these things combined.
Yeah, you can't probe any deeper without essentially influencing the outcome of your experiments more than you learn from them. So anyway, which is not exactly the question you asked, but it's, it's
Yeah, we're not going to get there from here, is my
randomly interested. Nancy Graziano notes, by the way, for the Facebook Hangout-a-thon, there are 22 members listed as going and 23 additional members listed as maybe. So hopefully this year's event will be at least twice as successful as last year. So if you don't know, Nancy is the administrator of the Astronomy Cast Facebook page. We are eternally in her debt, and if you want to join it, just go. We really appreciate it. But if you want to join the Facebook page, by all means, go there and sign up. Neither of us are very active there because neither of us are huge fans of Facebook.
I have to admit, I use Facebook to talk with like my high school friends and stuff like that. And I tend to live on Twitter when it comes to momentarily mutterings of the universe, and Google Plus for things that I'm more thoughtful about. I needed a personal space.
I know. It's tough though. I mean, like literally, people have ways that they want to interact with us.
Yeah.
Right? And for them, they're very comfortable and they enjoy reading us on Twitter, or they're very comfortable and they enjoy listening to us through the podcast, or on YouTube, or on Instagram, and we've gotten to the point now where we have to, if we want to try and sort of stay on top of the conversations that are going, we have to be in 10 places at once, more. 15 places. There's the
We don't sleep very
there's
much.
the Cosmic Quest forum. There's the comments on Universe Today. There's feedback on iTunes. And each time a person posts one of these comments, they're like, we want to know and be able to interact. Like right now, I'm using the Q&A app, and I know some people are posting some comments over on the event page. And anyway, I know it's a good problem to have, that we have a lot of people who want to talk to us. And a lot of ways to do it, and we will try our best to show up in as many places as we can.
Thank you, Nancy, for making it so that we know when we have to be on Facebook, and for building a community that we're two humans. We need your help, and thank you.
Neo Tyson notes, Neil Tyson's Cosmos mentioned the fact that everything we can see in the universe is only because light has traveled for X billion years. Are there any theories operating with the assumption that the universe is older than the observable light?
No.
Whoa. Nope.
Not reputable theories.
No.
People can make up stuff.
And we did a whole series of episodes on like how big is the universe, how old is the universe, where is the center of the universe, and so the universe is definitely bigger than the observable universe. Whether it's infinite or finite, we don't know yet.
But the fact that the universe is 13.8 plus or minus a number I can no longer remember, billion years old, has been definitively shown through a number of different methods. That's our universe.
Yeah. But it's mind-bending that you could have it be infinite and yet finite in time.
It's infinite in space, but not infinite in age, and I actually kind of like that.
Yeah. Well, I posed that question to Mike Brown. I'm like, what is the universe expanding into? And he was like, well, the universe is expanding into time.
Oh,
I love that answer. It's expanding into time.
Feels like a cop-out.
No. He knew the sort of more the other answer. But Steve Peterson notes that Sir Roger Penrose was on NPR Science Friday on the 4th, and he had a lot to say about the Big Bang.
He's an amazing communicator. Go back and listen to that.
His books are just so thick and so interesting. I really have enjoyed some of his stuff. Was it The Fabric of Reality? What's the book he did? He did a book a few years ago, and really interesting stuff. I got nothing but good things to say. Was he the one who had the bet with Hawking about the nature of black holes? Was it Penrose?
I think so, but I may be convoluting multiple things.
Yeah.
I'm only on
Yeah,
my
the Hawking bet. Yeah. Yeah. So essentially, do black holes? This is, Penrose is the guy that, do black holes, consume information or not? Can information come back out of them? And Hawking and Penrose sort of came on opposite sides of this question, so and had a bet. I think Hawking says that maybe there's no such thing as event horizons. So, Carlito Brigante also asks, I've always wanted to know, is a black hole a circle, sphere, or is it a flat black hole?
It's a sphere. Well, okay, let me rephrase that. It's an ellipsoid, and the exact shape depends on its rotation rate.
Nice.
It's three-dimensional.
Yeah. And what's amazing is that you can rotate this black hole close to the speed of light, and the whole thing kind of flattens down, and the event horizon flattens down, and you get to the point where the event horizon is just about to reveal the singularity itself, and it doesn't, and that's where it stops, and that's the speed, the maximum speed that a black hole can rotate is that point where the event horizon is just about to reveal the singularity, which is just mind-bending. And we've talked about this. Thank you, Pamela. Hugo Burnham says, man, we've gone into cosmology speculation land. Your favorite. Is the universe bigger than it's observable because of inflation happening faster than the speed of light? So why is the universe bigger than it is observable?
It's because of the expansion rate. I mean, if you think about it, light travels at a finite speed, but because the expansion controls every small bit of the universe, it's possible for an object in the distance to be effectively getting carried away. It's not moving, it's not its own velocity, it's effectively getting carried away at greater than the speed of light because of this expansion.
And also, but we know that it's not bigger because we don't see any kind of mirror images.
We don't know that it's not smaller.
Smaller, yeah. So we don't see any mirror of features in the cosmic microwave background radiation. And so, if we saw, a happy face feature over on the left-hand side and a happy face over on the right-hand side, we would think that maybe we're just seeing the same thing. Therefore, the universe is smaller and it's just wrapping around.
And our ability to look for mirrored features on the two sides limits the size of the observable universe to a few % of the total possible universe. That's a limit. It could be that we're like a bazillionth of a fraction of the total universe, but we're limited to being no more than a few % of the entire universe.
Ricardo Rey Santos says, before we raise up into the cosmos to find communication with another source of life, do we really need to learn how to communicate here on Mother Earth?
I'd
both.
like that.
Both. I choose.
Well, I think if we can
find aliens.
If we can learn to communicate faster than we can raise the money for the telescope equipment, I'd be happy.
Mm-hmm. Right, but I think the point is how to get along. Can we learn how to get along here on Earth? They're not mutually exclusive. We'll do both. Ronald Minch says, I'm waiting on a new space invention, a new fuel, a new engine. We can make some awesome computers compared to 40 years ago, but rockets are still slow and heavy. Elon Musk and SpaceX are cracking this problem. We are almost there. Because the goal, Elon says, it's just about, imagine you would take your $50 billion airliner, or $50 million airliner, you would fly it for one transatlantic mission, land it, and then detonate it.
Yeah.
And that's, but instead we refuel them. And so this is Musk's whole plan right now, is to make as many parts of the spacecraft fully reusable. The rocket takes off, the bottom stage detaches and flies back to the landing pad. The upper stage goes around the Earth and then flies back to the landing pad, and so you end up with very small amounts that aren't reused. So I think if this can get figured out, we are very close to a revolution in spaceflight.
Slowly.
Do you concur? All right, we'll take one more question, and then why don't we wrap this up? Um, man, what do I want? So many. Okay, so Kevin Gill. By the way, Kevin Gill is the creator of the Apoapsis website
Oh,
and
cool.
has got just amazing simulations of stuff around the solar system. Go check it out. He recommends that you designate a graveyard orbit that would make retrieval and disposal a tiny bit easier, I think.
The issue is the energies required to get between orbits. You need actually a whole series of graveyard orbits. But yes, that is a completely rational idea.
And even it'd just be a requirement. Like if you're going to launch that rocket, it's got to be able to go to the graveyard orbit, and you can do it slowly. Take your time. Put an ion drive on it, and take your time to get there. But it's your responsibility. If you're gonna, someone's got to check to make sure.
Yeah.
Okay, cool. Well, let's wrap this up. So, hey, thanks to everybody for watching. Thanks as always, Pamela, to providing your brain. We really appreciate it. And one last reminder: hang out a thon.
April 26, 27. I'm hoping to even get T-shirts printed. Well, T-shirts so that you can order them from Spreadshirt that say "I survived." So come survive it with us, and that will be going up later this week. So stay tuned on Twitter, on Google Plus, and get the links to get your shirt to share with us.
Awesome. All right. Well, hey, thanks again. We'll see you all later. Pamela.
Fraser.
How you doing?
I'm doing well. How are you doing?
Good. As you can tell, I'm not in my normal blue room.
No, you're in a room with fabulous ceilings.
You like those ceilings? Those are pretty great.
I
These
totally
are
dig the ceiling.
these are a friend of mine's place, and it's pretty awesome. But yeah, so hey, Astronomy Cast. You know what's also really cool? I'm actually in Central Time right now, so I know what it's like to live in the future like you.
It's a good place to be, although your future is warmer than mine, judging by your T-shirt and my wool sweater and wool scarf. And
Yeah, it's like yeah, I'm in the South. I'm down in Louisiana right now. And it's like 20, 25 degrees out. It's so nice.
Celsius. He's speaking in Celsius, people.
Yeah. Yeah. So I now know that we don't get jetpacks in the future. So
No, sadly not yet.
Anyway, how's everything going?
It's going well. I think the highlight has been everyone sending me the skydiver almost getting hit by a meteorite and going, is this real? And going, no, I don't think so. But and I'd love to hear your thoughts on that.
Sure. So I'm gonna say so. Philip Metzger from NASA has run some simulations, and either it's a very tiny pebble, just a few, just like a few centimeters away from the camera, something, a rock, or it's a